In this lesson, we'll build an intuitive picture for atmospheric stability and answer two common questions about conditional instability and latent heat. First, let's set up a simple temperature versus height diagram. The horizontal axis is temperature, and the vertical axis is height. We draw the environmental temperature profile, called the environmental lapse rate. In a conditionally unstable situation, the environment cools with height at a rate between the moist lapse rate and the dry lapse rate. We'll also draw reference lines for the dry adiabatic lapse rate, about 9.8 degrees per kilometer, and the moist adiabatic lapse rate, typically between 4 and 7 degrees per kilometer. Now, let's launch a tiny air parcel from the surface and see what happens. Below cloud base, the parcel is unsaturated and follows the dry lapse rate, which cools quickly. At the lifting condensation level, it becomes saturated, clouds begin to form, and latent heat is released. Above cloud base, the parcel cools more slowly, following the moist lapse rate. Because the environment cools faster than the moist rate, the saturated parcel becomes warmer than its surroundings and keeps rising. That's instability. Now, let's answer. How can a conditionally unstable atmosphere become unstable? Remember, below cloud base, the parcel follows the dry rate and tends to be cooler than the environment, but above cloud base, it follows the moist rate and can become warmer. So, the key is the rising air must become saturated. Concept recap. Conditionally unstable means the environmental cooling rate is between the moist and the dry rates. Unsaturated parcels cool along the dry rate and are stable. Saturated parcels cool along the moist rate and can be unstable. Next question. True or false? Latent heat released by cloud formation causes an air parcel to cool. This statement is false. When vapor condenses into cloud droplets, latent heat is released into the parcel. That energy input warms the parcel relative to how fast it would otherwise cool, and that's why the moist lapse rate is smaller than the dry lapse rate. Summary. A conditionally unstable atmosphere becomes unstable when rising air becomes saturated. Condensation releases latent heat, so saturated parcels cool more slowly and can become warmer than the environment, accelerating upward. Latent heat release warms the parcel, so the statement that it causes cooling is false. Great job!